Hello everyone. My name is Ushal Sharma, and I'll be taking you through the project that we're doing for our final year as our final year project, and that is malnutrition detection in children below 5 years using machine learning. So actually, how this project is that we're going to make a mobile-based application in which malnutrition will be integrated, so that we can actually use it to detect malnutrition in children below 5 years. So more information will be given as we go through. So let me take you. So this is the table of contents, and let me start with the background motivation. So now, background motivation is that health is a fundamental pillar in human being, influencing our lives from daily activities. So as stated by WHO in 1946, health is not merely the absence of a disease, but it's also the well-being, both physically, mentally, and socially. So it's not just absence of a disease. So good health encompasses a magnitude of factors ranging from a good diet to a healthy lifestyle. So it encompasses a variety of things that, as you can see here. Now, nutrition is an important aspect in a good health. And because if you define malnutrition, it has very many definitions, but the one which we felt was right was it's a supply of sufficient energy and nutrients to the cells in the body in order to for them to carry out their normal functions that they're supposed to carry, that facilitate growth, reproduction, defense, and repair, and among others also. So basically, it's having nutrients in the correct, like I say, in the correct quantities, in the correct proportions, a variety of them, vitamins, carbohydrates. So that's all nutrition. Now, the health and nutrition status of children is one of the benchmarks that indicate the nutritional condition of a wider community. Now, because obviously, if you have children in a community that are not malnourished, you don't expect the community also to be healthy either, because obviously children are going to be the part of the community as they grow up. So malnutrition can be manifested through being underweight, wasted, and stunted. So these are actually the main things. Underweight, we all know that a person whose weight is low, maybe according to the height or even age. Now, wasted is whereby there is a low weight ratio to the height. So someone can have a low weight to the height. So that's so there's also one more that is stunted. So stunted, actually we measure it with the height and the age. So if a person's height is less compared to the age, we can call that person stunted. And that's another way of measuring how malnourished a person is. So these are the three main things that we use: underweight, wasted, or stunted. And these are indicators. Actually, they're even in the WHO's global reference, a list of 100 core health indicators. Now, globally, 45.4 million of all deaths among children under 5 years of age are linked to undernutrition, and many of them are in developing countries. Now, if I look at the statistics of Uganda, you can see the urgency of this situation. This is just to show you how bad this situation, not only in Uganda, but even in the world. So it has to be treated with technology so that you can use it. Now, one of the methods that to assess malnutrition in Uganda includes traditional ways like dietary and medical evaluations, significant weight loss, body weight, that's skin thickness, and also there's another one that we call the door-to-door information gathering. But the problem of these systems is that they are really time-consuming, and actually many children that are malnourished may go undetected, so they might not get the treatment at the right time. So our project aims to address these challenges by improving the accessibility and enabling early detection. That's the main key: early detection of the malnutrition in children by harnessing technology and community engagement. So if you can get to know that this child is malnourished at the early stage, there are better chances of treatment and survival. So yes, this was the part of the background and motivation.
Hello, my name is Isma Chris, and I'm going to take you through this next section of our presentation. So, in the problem statement, you see that we have existing methods to detect malnutrition in infants already, but we face significant challenges when using these systems, as most of them use only one set of data, that is either numeric or image data, but separate. So, in our project, we're going to combine this sets of data, such that they work hand in hand and provide better malnutrition results. Of course, the other thing is about the current systems being used are platform-specific to desktop systems, so making them inaccessible to a wider population, as most people have handheld devices such as phones, mobile phones. So in our project, we're going to make a cross-platform application that is accessible on all devices, not platform-specific. So our main objective is to develop a machine learning model for early detection of malnutrition in children. And this model, we're going to look at steps to come up with this model in the methodology, and the specific objectives, which are first collect data, both image and numeric data, to be used as input for the model, and it's also clean data in order to remove noise. Because when you look at in the data exploration, during data exploration, you see that our data may have inconsistent values, have missing values and outliers. So we need to prepare our data in such a way that it does not have those kind of values. And then we should also train the model using a diverse data set to improve the accuracy and also evaluate the performance of the model through testing using the confusion matrix. Here we should also look at several evaluation metrics like precision, recall, and so on. So the scope, of course, we're going to use image and numeric data, which will be obtained from trustworthy and reliable sources like UNICEF. The model is meant to detect malnutrition for only children below 5 years of age. So that's where we specified our model, like the age is going to stop. And the significance, of course, we use this model. It's going to contribute to the field of machine learning and AI by applying technologies to address this issue in public health. And it's the app's development and implementation also offer practical solutions for early detection of malnutrition, so that the caregivers and parents have actionable insights, they can easily give action, they can easily act accordingly from the results they get from the model. It also fosters a sense of community and support among parents through the chat forum. Of course, we're going to come up with a chat forum that is used where parents meet and discuss relatable challenges they face amongst their kids. And it's also addressing child malnutrition early can also reduce healthcare costs because it's better to know the problem early and act on it rather than wait for it to become worse. Thank you.
Hello everyone, my name is Birunji Mary Immaculate and I'm part of Group 13. I'm going to take you through the literature review. So in the literature reviews we made, we realized that there were two methods that were being used. Some were using the traditional methods and some were using the IT-related methods with the help of machine learning mechanisms. So to start with Dr. Krishna, this one carried out a study using support vector machine to predict malnutrition in newborns. They had very good work and they were able to highlight the SVM's effectiveness in handling high dimensional data. But we realized that this method, yes, it's good, but it has one challenge of computational expense and sensitivity to kernel and high parameter choices. The other work still was using machine learning and they used various algorithms. They used very many algorithms and they chose the one which had the best accuracy. But looking at this work, we realized that accuracy is not the only metric that can be used to show effectively the performance of a model. Then another work, these ones, they used logistic regression and they found out that the incidence of low birth weight in India, it was a study carried out in India, was linked to the mother's nutritional status. So they realized that a kid's nutrition, status of nutrition, depends on the mother's nutrition status. That is, it means they also looked at things like breast milk. If the mother cannot breastfeed the kid very well, there are high chances of that child being malnourished. Going on to the next work, this was a study carried out in Latin America, and those ones were looking more of height. It means they used the anthropometric index of height, of stunting, to determine the malnutrition in children. Another study, which is traditional, it was still about detecting malnutrition, and they were looking at things like the economic status of a family. Like if a family is wealthy, there are high chances of having healthy kids. If they are poor, there are high chances of having malnourished children. And then another study was carried out to analyze the infant mortality factors using regression analysis. While they were looking at the infant mortality factors, the higher infant mortality, it means there's a higher rate of malnutrition. Like most of the kids are malnourished. That's what they were looking at in their study. Another study used image analysis. Image analysis is a good approach actually, but then we realized that someone may look lean, but they are not actually malnourished. And we also realized that some indices of malnourishment, because we have stunting, wasting, and overweight, you cannot accurately predict that someone is malnourished just by using an image that they are fat or maybe they are short. Someone may naturally be short but not malnourished. So yeah, that's what we look at. That's what this study had. So the difference our work is going to have is that we are going to create a balance between use of numerical data and image data to detect malnutrition, because we realize that some factors may not accurately be measured using numerical data and some may also not accurately be measured using image data. So that's the difference with our work, that we are going to create a balance between image data and numerical data to detect malnutrition. There is more work which we couldn't include in our slides because that would be a lot of work, but then we included it in our proposal. Thank you very much. I invite my next colleague to present the next part.
My name is Mokisa Ivan and I'm to be taking you through the methodology. So to start with, our model is to use both image and numerical data, as our system is to have two sections, one for receiving the child's image and the other section for the parent to actually input the child's details, their age, the weight, the height, and their sex. So the image data and numerical data are to work hand in hand. So the purpose of the images is to actually predict whether the child in the image is actually malnourished or healthy, and the data that has been input by the parent is to predict whether the malnourished child in the image is stunted, wasting, overweight, or underweight. So for the image data, we collected the images through web scraping through various websites. And after that, we had to resize the images to ensure standardization and consistency. And then we had to augment the data through flipping, rotating, and zooming. After that, we had to label them according to their observations in the images, whether that image is malnourished or for a healthy child. And after that, we had to split the data as 70% is to go for the training data, and the rest 15% is to go for validation and testing respectively. And for the training part, our purpose here is to create a deep learning model that uses neural networks. And first, we have to categorize the images in different folders, that is the malnourished images and the healthy images. And after that, we have to label the malnourished as malnourished or zeros and the healthy ones as healthy or ones. So after that, we have to split the data as I've talked about, the 70% for for the training and 15% for testing and validation. So the purpose of the neural network here is to take in the training data and perform max pooling, whereby it will simplify the image features, and after that it will create the dense layers that we will adjust by hyperparameter tuning, and this will also make the model able to understand those complex features like the bones of the kids. And after all that, it will use the ReL function to actually perform decisions whether the image is of a malnourished child or a healthy child. So that's all for the training. And for the model selection, we use CNN because this is a widely used OpenCV library that is efficient for performing such image classification tasks. And for model evaluation, we are to use the confusion matrix to actually predict, to make use of the precision, recall, F1 score, and accuracy metrics to find out that model that works best and actually go with that. So for the numeric data, we collected it from the UNICEF website and also the GitHub repository. And here we are trying to define the variables that are used in the dataset, whereby we have the age in years, the height in centimeters, and the weight in kilograms. And those features are to be used to predict whether the child is wasting, stunting, overweight, or underweight. So for the data processing, we are to clean the data through removing unnecessary columns like their income levels. Such columns and features are unnecessary for our model, and also find a way to handle outliers. So for splitting the data, for this part we are to use 80% for training and 10% for validation and testing respectively. And training the model, this numerical model, we are to use supervised learning techniques like random forest, support vector machine, SVM, and then neural networks also here. So for the random forest classifier, the way it actually works is that it randomly selects the features, be it age, height, weight, or sex. Then it creates a root node as you see here. So it again does the same process of randomly picking any feature. So that works as the child nodes. It does the same processes until it reaches the bottom. So what it does, it creates multiple decision trees, and how it actually works, this is it. It brings in the input data, whatever the user has put into the system, and it takes on the data to see whether it matches all these. So if the data at the end, it makes a prediction of whether the kid is stunting, and also the data is also passed into this and also passed through this. So you find that this tree will make a stunted prediction, and also this makes a stunted, and also this makes a stunted. This one will make like an overweight, and this one underweight, wasting. So what the model actually does finally is to find the result with the highest frequency. So if stunting has appeared here, it will label the output as stunting. So for SVM, it works in a way that since we are dealing with multi-classification problem, so it plots the data on a two-dimensional plane as shown here, whereby the green are underweight, stunting and wasting, red and blue, and it creates three different models, whereby in each model it receives a class and labels it as true. So if an input is received from here, it labels all this as true and the rest as false. So it creates a line and also does the same process for these other two models. And after an input is got, its position is calculated and the probability is got. So the probability of this model, and this model is got, and then the model with the highest frequency is taken. So if you find that this model has the highest frequency, then this thing will be the blue and it will be the wasting. So the output would be labeled as wasting. So that's how it is. We expect it to work. So lastly, for the neural network, we expect the neural network to work in such a way that since our data has many inputs and outputs, it is to create four vectors. So one vector might be for stunting, another one for underweight, wasting, and overweight. So it creates a matrix in such a way that it has 4 numbers, 4 rows. So this one might be for stunting, whereby the stunting is 1. This one is for the overweight, where the overweight is 1, and this one is for the underweight. So like that. So after that data is passed into the neural network formula, and it actually makes the prediction in these output layers as it is labeled as stunted, wasting, underweight, and overweight. So these are the input layers: child weight, age, height, and sex, and the output layers consist of these. So the model selection here, after making all those computations and different models, and training all those models, we are to pick the model with the most appropriate measure metrics. So after that, we are to again use confusion matrix for this numerical data, and also use precision, recall, F1 score, and accuracy in order to see the model that has worked best, be it SVM, random forest, or neural network. So the model with the best metric measures, will win. We'll take that one.
So these are our references, and thank you for listening.